Okay, so let's do 12.1. So a function of the form r of t equals f1ti f2tj, or r of t equals f1ti f2tj f3tk is called a vector valued function. So let's look at an example. Okay, I'm going to erase this now and write my example at the top. Okay, so here's our example. It's from practice quiz 2. It's number 1. Part of number 1. It says, sketch the curve represented by the vector valued function on 0 to 2 pi. And our vector value function is sine ti plus cosine tj plus t squared k. So let's do a table of values here. So let me write my table. Okay, so I'm going to let t be 0. So let t be 0 up in my function up here, vector value function. So it'd be then r of 0 then would be sine of 0 I plus cosine of 0 j plus 0 squared k. So the sine of 0 is 0, so it'd be 0. Cosine of 0 is 1, so 1, and this would be 0. So our point would be 0, 1, 0 at 0 for t. Let's next put in pi over 4 for t. Actually, I did pi over 2 instead. So putting pi over 2 in place of t, it would be sine of pi over 2 I, cosine of pi over 2j, pi over 2 squared. So the sine of pi over 2 is 1, so it would be 1. The cosine of pi over 2 is 0. And squaring this, it would be pi squared over 4. So let's go in increments of pi over 2 actually. So next one we'll do is pi. Okay, so sticking pi in, it'd be sine of pi I, cosine pi j, pi squared k. Sine of pi is 0, cosine of pi is minus 1, and you have pi squared here. Okay, let's go on now to 3 pi over 2 next. Okay, so I'll put 3 pi over 2 in now, so it'll be sine of 3 pi over 2, which is minus 1, cosine of 3 pi over 2, which is 0, and squaring 3 pi over 2, you'd have 9 pi squared over 4. Okay, and our last one, let's stick in 2 pi. So lastly, sticking 2 pi in, sine 2 pi, which is 0, cosine 2 pi, which is 1, and squaring 2 pi would be 4 pi squared. I'm writing that over 16, so multiplying top and bottom by 4, so it'll be 16 pi squared over 4. Okay, so we got some points now. Let's look at the graph now of these guys. Well, the first thing to notice actually before doing the graph is that the sine and cosine, so on the I and j here, they're going to be points on the unit circle, because the points on the unit circle are the form cosine sine. So these will go around the unit circle here, these ij guys, and the k will not, but so it's actually going to be, we'll draw in a second, but it's going to be wrapping around a unit cylinder, you'll see. So let me draw some things here. Okay, so drawing a cylinder here. So these circles are unit circles. Okay, and each tick mark on the z-axis, this z-axis going up this way. So each mark on the z-axis is representing, say, pi squared over 4. So that's going to be pi squared over 4, and up here, if you count them, there's 16 of them, that would be 16 pi squared over 4 for this one. Okay, so let's start plotting these. So here's the x-axis, y-axis. So let's plot 0, 1, 0. It's 0 on the x, 1 on the y, 0 on the z. So let me plot that. So it's going to be right here. Okay, because 0 on the x, 1 on the y, 0 on the z would put us right here. Let's next do 1 on the x, 0 on the y, pi squared over 4 on the z. So let me do that. So it put me right here, because it's 1 on the x would put me here, 0 on the y, and then pi squared over 4. So each of the tick marks is pi squared over 4. So it's going to be at that height, that tick mark. So it'll be right here, our point. Okay, let's next do the 0, minus 1, So I'm writing pi squared as 4 pi squared over 4 just so I can fit it on here better. So 0 minus 1, 4 pi squared over 4, let me graph that. Okay, so I graphed it here. So again, it's 0 on the x, negative 1 on the y, so negative 1 would be here. And then 4 pi squared over 4, so you go up 4 marks on the z-axis, 1, 2, 3, 4, come across this way, and then up this way, and we'll intersect with your point, so right there. Okay, so that's this guy here. Let's do now the negative 1, 0, 9 pi squared over 4, let's do that one next. Okay, so what I've done is drawn a circle here at the height 9 pi squared over 4, so it's pretty much up 9 tick marks here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, so right there. So drawing a circle at that height, the unit circle. So then negative 1, 0, 9 pi squared over 4 would be right here, because it'd be negative 1 on the x, which is over here, 0 on the y, and then up 9 pi squared over 4. So this circle is denoting height 9 pi squared over 4 on the z. Okay, so we've got that one now. Let's lastly do this guy. So it'd be up here, because the top of the cylinder up here is height 16 pi squared over 4, and it's pretty much directly above this initial guy, because it's 0, 1, the initial guy is 0, 1. The only difference is this has a different z value, so it's going to be straight up from that one, up at 16 pi squared over 4. So if you count the tick marks, there's 16 there. Okay, so now let's connect these dots. So it looks something like this. So it's pretty much wrapping around the cylinder. Let me take away some of the stuff in here so you can see it better. Okay, so it looks like this. So again, it's wrapping around the cylinder. So this is called a helix, this shape. So it's just wrapping around. So you get a helix whenever you have a sine and cosine in there, or say a sine of kt and a cosine of kt, and something else over here. So two of the components need to be, one needs to be sine, one needs to be cosine. Then it would be some sort of a helix. So the sine and cosine part here, we need that so it wraps around the cylinder. Okay, so let's move on. Right, so I'm going to erase this now and we'll move on. Okay, so if r of t is equal to f1i plus f2j plus f3k, then the limit x goes to a of r of t, we're going to define to mean limit x goes to a of f1 plus limit x goes to a of f2 plus limit x goes to a of f3, provided f1, f2, and f3 have limits as t goes to a. Okay, so let's take a look at an example. Okay, so example, find the limit if it exists. So limit t goes to 0 of r of t when r of t is equal to ti plus cosine tj plus sine tk. So let's use our definition up here. So let's write it down here. Okay, actually let me first bring your attention up here. I forgot to write the I, j, k up here when I first wrote this. So it needs to have an I in this guy, j here and a k here. Okay, going back to the example then over here, looking at limit t goes to 0 of r of t. Here's my r of t. So if you limit t goes to 0 of t in the I direction, limit t goes to 0 of cosine of t, j direction, limit t goes to 0 of sine of t, k direction. So let's work these out then. So the limit t goes to 0 of t would just be 0, so it's going to be 0i. And the limit t goes to 0 of cosine, well the cosine is 0 is 1, so it's going to be 1j. And the limit t goes to 0 of sine, well the sine is 0, so it's going to be 0k. So let me write my answer here. Okay, so it's going to be then 0i plus 1j plus 0k. You can just write that as j1 and 2 as your answer. Okay, so we're done with this example. Alright, so I'm going to leave this video here. We're done with 12.1, so I'll pick it up in the next video on 12.2. So let's leave it there.